Okay, in this video we're going to talk about synthetic division. Okay, a polynomial divided by a binomial. As you can see here, polynomial is your numerator, a binomial is your denominator. Now we can talk about this using a lot of theorems in Algebra 2 and in Pre-Cal. It's going to show you a very generic process using synthetic division, and then in each class we'll bring it together using whatever parts we want to use. So in order to do synthetic division, we have to look at our binomial, the x minus 1. We want to set x minus 1 equal to 0. So x minus 1 is kind of like a factor. We're going to equal it to 0. We're going to solve that factor to find a possible solution. So we get x equals 1 is a possible solution. Remember, solution means a possible root. And we're going to try to prove that, okay, using synthetic division. So we're going to take 1. We're going to put it in a little tiny box right here, a little halfway box, which doesn't make sense right now, but it will in just a minute. It's kind of setting up the problem for you. Outside of this box, we're going to list our coefficients. Remember, coefficients are the numbers in front of the variables. So look at your numerator, your polynomial. Your coefficient is going to be -3, -2, 2, and 1, always in the right order. So my degree needs to be going down, descending, and it is. So my coefficients are -3, -2, 2, and 1. I skip a line, I draw a line. So this is how you set up synthetic division, and we're going to get it started. Synthetic means to fake, so we're going to divide in a fake manner. We're going to divide without dividing at all, basically. In order to do this, your first number, so -3, always starts your problem off. It always comes straight down. And then from there, you want to take your possible root, so your 1, and you want to multiply it by your number. So 1 times -3, we know it's -3. So 1 times -3 comes up here, -3. Then you want to add straight down. -2 plus -3 is -5. You want to repeat that process. 1 times -5, that's -5. That goes up here. You want to add straight down. 2 plus -5 is -3. Repeat that process. 1 times -3 is -3. That goes here. Add straight down, and you get -2. Okay, this last number is the important number right here. It's pretty much what you want to focus on for now. This last number is called your remainder. Okay, so according to the remainder theorem, if this last number is a 0, so if the remainder is 0, then the divisor is a, can't see that, I'm sorry. If the remainder is 0, then the divisor is a root slash factor, depending on what you're looking at. So in this case, if the remainder is a 0, then a divisor is a root or a factor. Was my remainder 0? No. So what does that tell me about x is 1? So it was a possible root. So if for x is 1 we did not get a remainder of 0, is x is 1 a root? The answer is no. So in this case, x equals 1 is not a root. Okay, since x is 1 is not a root, then that also tells me that x minus 1 is not a factor. Alright, it does not mean we can't divide, because we just divided. We did it right here. We just divided. But we figured out in the end that x equals 1 is not a root, meaning x minus 1 is not a factor. But what did we find out? Well, we found out, so if the remainder is a number, not 0, then you found a point on the graph. So in this case, we would say f of 1 equals negative 2. Now let's make sure you understand that. F of 1 equals negative 2. That means, this is my x value. X was 1, right? And my answer was negative 2. So that means if I plug in to my original function, the original polynomial, if I let this be f of x, and I'm asking for f of 1, I guarantee the answer is negative 2. So synthetic division and the remainder theorem tells us whether we have a root or a factor. And if we don't have a root or a factor, then we have an actual point on the graph. Why is that important? Because remember, a root is a very important point on the graph. Remember, a root is an x-intercept. So no matter how you look at it, synthetic division is giving you a point, whether that point is a very special point in the root or just a very generic point in some random point on the graph. Very important. But this is synthetic division, and we'll do some more videos on this throughout the next couple days.